Welcome back everyone. In today's session we are going to see question number 2 of exercise 1.5, that is simplify each of the following expressions. You can see there are irrational numbers in all of these. In the last session we have discussed about irrational numbers, okay? All non-perfect square numbers like root 2, root 3, root 5, root 7. I said you these all non-perfect square numbers are irrational numbers. So you'll find here in question number 2 also. So let's see how to simplify each one of these by using algebraic identities. But before we go for question number 2, let's see some basic concepts. If you have a number like root 16, say root 16 plus root 9, what will be the answer for this? Root 16 plus root 9, will it be root 25 or not? This answer looks correct to you, isn't it? 25, 16 plus 9, when you add it you will get 25, and most of the students write root 25. Let's check it whether this is equal or not. Let's simplify both of them separately. What is root 16? Root 16 is 4 and root 9 is 3. 4 plus 3 is 7. So we must get 7 here also on the right hand side. But what is root 25? Root 25 is 5. So are they equal? What do you say? Are they equal? No. Root 16 plus root 9 is never equal to root 25. That is, we have a rule, root a plus root b is not equal to root a plus b. You cannot add the roots like this. Okay, this is the first rule. Same rule applies for minus also. Root 16 minus root 9 will never be equal to root 16 minus 9. Okay, what is 16 minus 9? 7. What is, let's simplify and check it why it is not equal. Root 16 is 4 and root 9 is 3. 4 minus 3 is 1, and if you subtract it in this way, 16 minus 9, this is root 7, but root 7 and 1 are not equal. Got it everyone? This is very important concept in this exercise, and you'll get these steps in your higher studies also. Never subtract the roots like this or add them in that way. Okay, you can simplify them separately. This is the correct way. If you get root 16 plus root 9, proceed in this way, 4 plus 3, and that is equals to 7. Individually you solve it, don't add it. Okay, if you get root 16 minus root 9, individually you solve it, don't subtract them, that will give you wrong answer. Root 16 is 4, root 9 is 3, and 4 minus 3 is 1. This is the correct answer. Okay, so finally I can say that root a plus root b is not equal to root a plus b, or root a minus root b is also not equal to root of a minus b. This is the first rule. Then let's see another rule now. What do you say about this one now? Root 4 into root 9. Can I multiply it directly? 9 4s are 36. Will it be right? Let's check out here now. Root 4 is 2, root 9 is 3, that is 6. 2 3 times is 6, and what is root 36? 6. So we are getting equal answer. Yes, so we can say that root a into root b can be multiplied in any way. Either you multiply individually, find the roots individually, then multiply, or you multiply it then find the roots. Both give you the correct answer. This doesn't happen in plus and minus. Okay, this doesn't happen when it is plus and minus. If you add and find the root, you are getting 5 here. If you find the root separately, you are getting 7. Yes, so which is correct here? This is correct. Individually you should do it, and if it is 25, this 5 is correct. So I can say that root a into root b is equal to root a by b. Similarly, root a by root b is equal to root a by b. This is also correct. So this is equal for division and multiplication, and for addition and subtraction they will not be equal. Remember all these rules. These are important for MCQs questions. Okay, let's see few more basic things because this is a new concept. Now if I have a question like 3 root 2 and 4 root 2, so what will be the answer for this? You can write 3 times root 2 and 4 times root 2. When you add, you will get 7 times root 2. Okay, you should not write root 4. 7, it's like 3x plus 4x. You can add the like terms. You learn about like terms and like terms. These are like surds. These numbers, irrational numbers, are called surds. S-U-R-D-S. What do we call them? S-U-R-D-S. Surds. So these like terms you can add and write 7x. In the same way you can add like surds and write them like this. Next, if you have 3 root 3 plus 5 root 7, can you add it? No. Like, can you add 3x and 5y? You cannot add it. Okay, 3x plus 5y cannot be added. It's 3x plus 5y only. So in the same way, like we cannot add unlike terms, we cannot add. In the same way, we cannot add unlike surds also. We should leave it here only. This is root 3, this is root 7, so you cannot add it. These are unlike surds. Okay, so this goes in this way. You can multiply unlike surds, but by using the third rule. If you have unlike surds, you can multiply root 3 into root 2. You can multiply, you can write root 6. Okay, if you have 3 root 3, then this 3 will also come here, 3 root 6. So the numbers in the root should be multiplied and the numbers out of the root should be multiplied separately. If nothing is here, this will be 1 root 2. 3 ones are 3. And okay, if I have another, if I give you another bit like this, 2 root 5 into 2 root 5, what will be the answer for this? So multiply the numbers which are out of the root, that is 2 times is 4, and root 5 into root 5 is root 25. So root 25 is how much? Root 25 is 5, so 4 into 5. 4 5 is 20. So answer for this is 20. So this is the way we simplify. Let's see this question number 2, which you have to get perfect in this concept because you have to solve, rationalize the denominators. Rationalization concept you have to learn. This will help you a lot in rationalization, but still you need practice for it. You are not perfect still. So let's begin with this. First bit, multiply 3 plus root 3 and 2 plus root 2. Okay,